Thank you, Andrew, for joining me in our inaugural effort to explore what folks are doing across IQ metrics. Can you just please start, introduce yourself, tell us a little bit of what you're doing?
Sure. Well, my name's Andrew Kuipers. I'm an independent contributor for the product development leadership group. So most of what I do is, well, look for opportunities to contribute and help others to learn and improve our systems. Kind of look at architecture across the board, but also dive deep on other concerns. One of my passions is also, well, helping level up developers and increasing their knowledge and presenting topics that they might not be familiar with. And so I actually have a presentation this afternoon on a functional library for C#. So this kind of ties in nicely with that.
Oh, that's really cool. You're in a very enviable position of sort of being a lot of like a floater and a troubleshooter for a lot of different areas and stuff. That's pretty
Yeah,
cool.
it certainly, I don't know, keeps me on my toes. Always interesting and new things to tackle.
That's cool. Not that it matters these days, but also you're in Regina,
Yes, I
just
am
so people know. Cool.
in my living room in Regina. Yep.
So we've chosen functional programming as the specific area that we're going to take a look at. And so let's just get right into that a little bit. The first question is, why is this topic interesting? And I think part of that is just for you to lay us a groundwork of what functional programming is as well.
Sure. Yeah. I guess from a high level, why it's interesting is it's a different paradigm of programming. Traditionally, a lot of developers are brought up in what we call the imperative programming paradigm. So that would be structured programming, object-oriented programming, where you're very discreetly telling the machine how to do things, the sequence of steps of execution, that sort of thing. Functional paradigm starts to move us over towards a more declarative paradigm of programming. So instead of spelling out all of the little steps, we're more describing what the outcome should be and what the relationship is between the inputs and outputs. Now, one of the reasons why we'd ever want to do this and move away from our more classic paradigms into something like functional programming is that it helps us cut through a lot of complexity. One of the things we found with the kind of open-ended aspects of the imperative paradigms, being able to just, mutating state, for instance, is one of the big things. I get to change this variable. Seems like a very simple thing, but it actually introduces a lot of complexity into our software, a lot of different possible paths that the program could take. And so by moving towards functional programming, which has some unique properties like focusing on using pure functions, which are a bit more of a mathematical concept. We can touch on that in a bit. And also focusing on immutable data, not actually being able to mutate and change the state of data that might be referenced from various places. These come together to actually cut through a lot of complexity, which means less bugs in our programs. It's easier to understand and reason about these things. It's easier to go and read them. Obviously, once you've got over the hump of understanding the syntax of how this functional language, F# or Clojure or Haskell or what have you, how that differs from the programming languages you're used to. Once you've gotten over that, though, and you understand the syntax, the semantics are actually quite a bit easier to wrap your head around, and you've got a lot less room for those little hidden gotchas and those other things that trip up programmers. So I think from a high level, that's kind of the why we might care about this.
So a couple things come out of that for me, and this is where my superpower of asking stupid questions comes in.
Please.
First of all, you talked about imperative versus declarative early on, and that immediately twigged for me that I think the reason that computer programming is typically declarative is because uh, we all know that if you don't very specifically tell the computer what you want it to do, it doesn't know. It's like complex and everything, but it's also super dumb. So I watched this video where a dad uh, had his kids give instructions about making a peanut butter and jelly sandwich. And every time they didn't specifically say a thing, he would just misinterpret it. And
Mhm.
they had to be super declarative. So, how is it that functional programming can be imperative and simple? Like, where does that misinterpretation go? And I told you it was going to be a
Yeah.
stupid question.
Well, no, it's not a stupid question at all. Though I do have to make a minor correction there. So the languages we work in are the imperative ones.
No, sorry, I've got it
Functional is the
backwards.
declarative ones. Yeah, yeah, not a
Okay,
problem at all.
okay,
They're
okay.
new terminology. Because remember, the imperative, like the imperative tense, things like that, is saying do this, do that, do the other thing.
Right.
I'm
Okay.
commanding
Okay.
you, right? Whereas
Thank you. I had him
declarative
back.
is saying this is what I would like to have done. Go and figure it out. So when you say to the dad, I would like a peanut butter sandwich to be on my plate by noon, right? You're in declarative mode. Whereas when
Awesome.
you say, Dad, go to the kitchen, open up the cupboard, pull out the peanut butter jar, blah, 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 you're in imperative mode, right? Um, Sorry, and I think I kind of
Yeah.
missed exactly what your question was. So
What?
imperative versus declarative, why might we be in either mode?
How can we, or how does functional programming have success, even though you're putting more value towards the end state? You're saying I just want it on my plate at the end. Eh, Like how can like
How
the
can you work
magic
with a language
the
like that?
the magic of all that simplicity is great, except we know that when we go that simple, computers misunderstand.
Yeah. Hmm. That's an interesting question. Um, and I guess there's functional programming is one style of declarative language where it's usually the mapping between the semantics, what you would like to happen and what actually happens on the machine is still fairly deterministic, right? Um, and I think that's where that might be the answer to your question as far as functional goes, is that there's a deterministic relationship. When I say that there's a mapping from this set to that set, I'm going to filter out all of the integers that are odd, right? So I start with the integer range. I'm going to declare over here, I would like all of the integers which are not odd and are greater than 42, something like that, right? And I declare that relationship, but I know that each one of those statements that I declare start with the range of integers, filter out all of the odd numbers, filter out anything less than 42. Now I've got my new set, right? I know that there's a deterministic computation that executes behind each one of those declarative statements. And that's what gives me the certainty. However, I don't actually need to tell it what all of those little things are. I just know that's already been done for me. That deterministic relationship. Though there's another declarative language out there where things get confusing, and I hope not to sidetrack too much over here. But have you heard of SQL, or as we often pronounce it, SQL?
Sure, absolutely.
Yeah, that's
It's
the
a
database
database thing.
language. Exactly, where you're stating, okay, I would like to, select these columns out of this table and join it with this other table and etc. That's the declarative programming language, right? But it has a bit of a different property than the functional declarative language. In SQL, you don't actually know what exactly is going to happen. And that's one of those frustrating but fascinating things about SQL is that you've got this, it's technically artificial intelligence going and doing query optimization. You say, I would like my result set, which is, this table and that table and joined in these ways and filtered in these ways. But you're not saying how it's going to do it, what it's going to load into memory here and there, how it's going to pull that data off of that, which hash sets or other things like that it's going to use to do these computations. It's actually got this AI algorithm running in the back doing an optimization problem because these are tricky problems, especially as your data is getting big. What worked yesterday when you had 100 rows might not work today when you've got 1,000,000 rows, right? So it's using statistical analysis and all these things to figure out exactly what to do. But from the programmer's perspective, we just put our trust in that execution engine and we know it's going to produce us the result most of the time. Most of the time, actually. But if you've ever talked to the ops folks and whatnot, every once in a while they'll grumble and talk about having to kick a bad query plan out of cache or something like that. Well, that's because this execution engine, which normally optimizes really well, sometimes doesn't get a great solution to the problem. And we can't deterministically tell it, you must do these steps in order. We just have to trust that it's going to do its thing. And because of this, this fundamental problem that we've got with using AI to solve hard problems, like what's the best sequence of operations to do to construct this table in the way that I would like, we've got this no free lunch theorem that states that for any heuristic you're using, any optimization algorithm you're using, there will exist cases for which that optimization performs terribly. And you can't avoid that. As soon as you start getting into optimization and AI territory, all of a sudden you're up against no free lunch. So that's a bit of a tangent, but that's just another example. So in functional, we have this nice deterministic semantics. We know, okay, if I request these, sets to be filtered like this way, it'll happen exactly like this. But we also have declarative languages for which we don't have that property. They're non-deterministic. They'll execute differently under different execution scenarios, even though we've given it exactly the same commands. But we can still work with this because it produces us results, and we don't often actually need to know all of the fine-grained instructions it executed to get to that result. And so that's kind of, sometimes we just trust in the magic.
So this ends up being sort of more of my marveling at coding period than about functional, but I think it does connect, which is I marvel at how software development continually grows and stacks on top of the thing that got solved before.
Mm-hmm.
So I've learned that a ton of using C# is relying on really brilliant libraries that other people have built to solve all sorts of things. You don't
Mm-hmm.
have to know how to sort a list. You just have to require or rely on somebody else's sorting skills and then use it.
Exactly.
And so it's this trust in the black box. And one of the things I feel like you're saying about F# is, or sorry, for functional, is that this is a new level of trust in the black box. All of the specific instructions required for the computer are still there, but we get to abstract even higher and
Yeah.
say, I just want the sandwich on the plate. And,
Yeah. And you reminded me of actually an interesting historical property of functional languages. So back in the day, we didn't have any programming languages. Like we were literally working in the ones and zeros, right? And then Grace Hopper came along and came up with assembly languages. And we're like, okay, we can assign these short mnemonic codes, which map like one-to-one off of to those ones and zeros. So side note, usually, we talk in hexadecimal and not pure binary just because it's easier to wrap our heads around, but it's basically the same thing, right? So assembly is a one-to-one mapping, and then we start to get those structured programming languages building on top of that, if statements and while loops and other things like that, right? But they fundamentally get turned into assembly statements, which get turned into the ones and zeros, etc. And that's the progression of our imperative languages. They grew up from ones and zeros to assembly to simple structured programming languages to object-oriented and et cetera. But functional came from a different direction, actually. Functional programming, the paradigm itself, is rooted in the work of Alonzo Church in like the 1930s, right? Before we actually had computers and programming. And he came up with his concept called the lambda calculus. And that's historically why we often talk about like anonymous functions as being lambda functions and things like that, is rooted in Alonzo Church's lambda calculus. which came from mathematics. And so where on the one side, most of our imperative languages have grown up as stacking on top of the assembly, right? Functional actually comes from the different direction, and it started in pure math territory, and it's working its way towards the specificity of the machine. And now they're kind of meeting in the middle,
Oh,
right?
wow.
And so now we're in, like the presentation I'm going to be giving this afternoon, we're taking imperative languages like C# and mixing in a few more functional concepts, right? But functional is coming from math and coming back towards the machine, adding in and kind of almost in a way weakening those mathematical concepts. Up here in the heights of math, we want only pure functions, right?
Yeah.
But in the real world, we actually need to cause side effects. That's how we get things on our screen, bits sent across the Ethernets, files saved on disk. Those are side effects. Math wants nothing to do with that, but we want some pragmatism. We want some practicality. And so we're trying to lower the bar a bit. And so, yeah, we're getting this neat meet in the middle effect where we're getting a best of both worlds, the clarity
Okay.
and the power and capabilities of, well, doing things imperatively on the machine.
That blew my mind. I'm going to describe is that um, uh, uh, software development is just constantly changing, and people have to be good at the next iteration, the stacking. It's going to change multiple times, generations worth, all the time for individuals. But you're talking about it's not being good at the next step and doing it. You're talking about an actual shift from a different direction of stuff.
Yeah, yeah. And I mean, this is where you get into discussing things like paradigm shifts, right?
Yeah.
It's not just another incremental capability into our languages or anything like that. It's a bit more fundamental than that. Though interestingly enough, again, like I said, like this stuff was dreamed up in the 30s. My understanding is technically like the functional paradigm came before the other ones, right? But it was hard to work with. We also didn't have great compilers for it or other things like that. It didn't work efficiently on the machines. Like I've got friends from grad studies and university that love their functional languages, done a lot of research on this stuff, but they freely admitted that this wasn't, very practical for actually doing like business production worthy software, other things, because taking these mathematical concepts and getting them to run efficiently was really difficult. But we've had a couple things happen. We've not only had the increase in computing power, we keep climbing that Moore's law curve, but we also have been optimizing those functional compilers. So now, in really just this past decade, has functional programming become more feasible as a way to solve practical problems and write programs rather than it being something really relegated to the realms of academia and whatnot. But also, our imperative language software is getting so bloody complex, right? All of the interactions, and we're finding more and more bugs and stuff just start emerging out of this vast complexity. And we keep adding complexity because our machines keep getting more powerful, so we can keep throwing, it's not just 10,000 lines, 100,000 lines, we're millions of lines of code, right? And we can get away with that, but the complexity makes it hard to wrap our heads around. And so we're looking for our options to cut through that complexity and simplify things a bit. And so again, you get a meet in the middle effect of functional is like, hey, now we're finally at the place where we can be run reasonably on modern hardware. We've optimized our compilers, etc. So you can do this. And the industry is like, we need something like this because our imperative languages and all of the software built in this way is getting out of hand, right? And so we're in that fascinating period right
Okay, Andrew, I'm always going to struggle to keep these under 10 minutes or so.
now.
And you are somebody that I could do this for 3 hours with and we'd forget that. So I just want to go to brass tacks,
Yeah,
a couple
no
of
problem.
questions here.
Sure.
How critical is it for people contributing IQ metrics, um, or what level of functional do people need to incorporate into their thinking in a year, in 5 years? Like uh, what's the call to action for someone who actually understands what you were talking about?
Yeah, I'd say the call to action is like, you don't need to right this second dive straight into writing all of your code in F sharp or Clojure or anything like that, right? Um, but what you should be doing is looking at what it is about functional languages that help you cut through that complexity. And the two big pieces are pure functions, right? So that is the output of a function is based purely on its input, and also pure side effect free function. So its output is based only on its input, not some other variables contributing to that, right? You've got parameters, and the output is derived from those parameters. And it's also not causing side effects onto other things. It's not tweaking some other variable. It's nice and pure. These are often in something like C sharp. That's just a simple static method that also isn't changing static variables or anything like that. Forget about static variables. We never use those anymore. But static methods are nice because they don't depend on class variables or other things like that. So that's step one. The other part of it is wrap your head around how to use immutable data structures. Mutation is one of those big causes of complexity. When I assumed this value is going to be this, but calling off to this function or something like that, went and changed it, and I depended on it being the way it was, but something else snuck in there and changed it on under me, and now that assumption doesn't hold. Well, if you can get rid of that possibility and just focus on, I have been handed an immutable data structure, the data is as it is, 10 lines later, 100 lines later, 1,000 lines of execution later, it will still be exactly the same as it is. Nobody snuck in there and changed those values on me. Both of those things together, you can do in any imperative language today, right? Like functional brings in all sorts of cool pattern matching stuff and other things like that, some really nice syntax for declaring things that makes your life easier, but it doesn't fundamentally add in something. Actually, this is a whole different discussion. Functional languages actually take away your capabilities. They don't add them. You can maintain that discipline to take away those capabilities yourself, focus on pure functions, focus on immutable data, and you'll make everybody's lives easier.
Let me simplify what I just heard. You
Sure.
can do it in C sharp. F sharp is really interesting and helps you focus it, but you can do it in C sharp.
Totally.
I
And
think
that's what
everybody
I'll
knows.
be presenting this afternoon is
Cool.
a library that helps you do some of these things in C sharp. By
Okay,
taking away your use of null, and that's a totally different subject, but take away the use of null and you simplify a lot of things. It's cool.
and so there's some practice elements in there. Where else can people learn more about it? And before you answer, I'll just plug, you do a weekly a Better Coding Book Club, which very often talks about this stuff. But what else would you recommend for somebody who wants to dig in a bit deeper?
Yeah, there's tons of great resources on the internet, blog posts and such. Mark Seaman is one of my favorites. Pla.dk, I think, is his blog. I just have it bookmarked. But he's got a lot of good stuff on transitioning from imperative to functional. I know Uncle Bob, of clean coding fame. If you just Google Uncle Bob functional, he's got a great little explanation. It's like a 40-minute conference video on this. I think he's got a couple, actually. And then there's books out there. Domain Modeling Made Functional by Scott Lashin. It does actually look at F sharp, but it doesn't focus on F sharp. It mostly focuses on the concepts and why they're valuable. Just plugging it because we recently finished it in book club, and it was great. There's another one, Functional Programming in C sharp, looks at how to do a lot of these things, use immutable data structures, use pure functions, option and result monads and things like that, but in C sharp, that language you're all familiar with. Yeah, there's I don't know, a ton of resources out there if you just plug in something like functional in C sharp into Google.
Andrew, thank you. You and I can talk for another couple hours after I press stop on the recording, but this is awesome. Thank you very much. Hey, and if you'll indulge me, just anybody else who's watching this, if you've got something you want to share, talk about, share with others, or you're just excited about, I want to keep doing these. So please let me know, reach out to me, and we'll get you on video as well. Thank you
Thank you
very
very
much
much, Nevin.
for coming.